Okay, so good morning everyone. Thank you all for coming to this talk called Property Wrappers or How Swift Decided to Become Java. So I'm Vincent, I'm French, and as you can guess, we are going to talk about iOS, we're going to talk about Swift, and we're going to talk about property wrappers. But first, we're going to see something a little bit different. We're going to see some Android code. So this is some Kotlin code, and this is the kind of code that you could find yourself writing in Kotlin on Android if you want to make network calls. So this is what a network call looks like in Android when you use a library called retrofit. And what I want you to see is that this is a little bit weird for us Swift developers because first, the service is implemented as an interface, so it's what we would call a protocol in Swift. And we can see that there are all these little annotations around the function. We can see an annotation that says, okay, so it needs to be a form that is URL encoded. There is another annotation that says, okay, this is the path to the endpoint that we are calling. And then inside the function signature, we can see that the arguments are also annotated. There is one annotation at header that says, okay, this is a header parameter, and the key for it is authorization. Then there is a field, so it's a field of the form, and there is the name of the field that's also provided as an annotation. Same thing for a second argument. And basically, what feels a little bit weird is that there is no actual code, there is no actual implementation, because everything that the framework needs to know in order to make the network calls is already being provided through these annotations. And so for Kotlin and Android developers, the annotations, they are really great because they let the developers basically decorate their code, because these annotations, they carry a meaning. This meaning is going to enrich the behavior of the code. Think about the annotation that says, okay, this is the path of the endpoint. This is the key that I need to use to encode this argument, etc. And basically, they let the developer extend their code in a very declarative way. Because when you declare a network call in retrofit, you're not saying how it is implemented, you say what it should do. You say, okay, this call, it should use this endpoint, it should encode this argument. You do things in a declarative way, and this is something that we want as developers because it helps us have a good separation of concerns. It helps us have code that is more readable and more maintainable. So this is cool, but unfortunately for us Swift developers, we didn't, until recently, have annotations, so we couldn't use this kind of pattern. But then something happened in June of this year, so there was WWDC 2019, and during the keynote at the beginning of the conference, there was a new framework that was announced. It's called SwiftUI. I'm sure most of you have heard about it. And if you remember the keynote, this is the first chunk of SwiftUI code that was shown to the world, to the people outside of Apple. And you might have thought when you saw this, what is this add state there? So this add state, it's a new edition of Swift 5.1, which are called property wrappers. And basically, they kind of introduce the idea of custom annotation to Swift. So this is a SwiftUI piece of code. It's like some kind of a hello world in SwiftUI. It's very basic, but we can see that there is this add state annotation. And we can see, if we know a little bit about SwiftUI, that it carries meaning, because basically when the content of the variable name is going to change, it's going to trigger a refresh of this UI. So add state is going to encapsulate some meaning that we're going to be able to use by saying, okay, this property needs to have this behavior. I'm going to decorate my property with this behavior. So add state is what Swift calls a property wrappers. And property wrappers, as I said, they are meant to decorate a property with a custom behavior. And of course, when you see it, you think, okay, it's really similar to annotations in Kotlin Java. So of course, there are lots of the patterns that they have in Kotlin and Java and Android that we're going to be able to use in our iOS code bases. So first, I want to begin by giving you some information about property wrappers, how they work, how they are implemented. And a good place to start to understand how they work is to actually look at the Swift evolution proposal. So it's basically a markdown file where the people that wanted to have property wrappers in Swift pitched the idea. They said, okay, this is why we want it. This is the kind of things we could build with it. And we are going to just look at the introduction of this evolution proposal because it already gives some very good insight in what motivated the addition of property wrappers to the language. So I'm quoting, the authors say that there are property implementation patterns that come up repeatedly in our code. And you can think of things like looking at the user default or maybe triggering a reload of your view. These kind of patterns that they come up repeatedly, they work around properties, and basically they trigger a lot of boilerplate in our code. We need to write boilerplate in order to add the behavior to the property. So the people who wanted to have property wrappers, they said, okay, well, rather than have a hard-coded fixed set of patterns inside the compiler, because you already have ways to add behaviors to property. You have the keyword lazy, you have the attribute NS scoping that do exactly this thing, but they have a very strong limitation is that they are hard-coded inside the compiler and you cannot write your own attributes. So they say, okay, well, why shouldn't we provide some general property wrapper mechanism that is going to allow us to implement this pattern of adding a behavior to a property as a library, meaning as something that is user-defined, developer-defined. So to understand how property wrappers work in practice, we're going to start and implement some of them. So the example I'm going to show you, they come from an article from NS Hipster. So if you want to see more examples like this, I can, of course, encourage you to go see this link. It's a very good article. And we're going to start by doing something very simple. We're going to look at how we could clamp numerical values. So clamping numerical values, it means that you give an interval and you are going to make sure that your value does not leave this interval. It can make sense in a lot of situations. One that you might be familiar with, you have some throwbacks of your chemistry classes is the pH of chemical solution. So it's a value that's supposed to be between 0 and 14. And it doesn't make sense for it to be less than 0 or more than 14. So with property wrappers, we could implement something like this, an @clamping attribute to which we provide an interval. And then when we set a new value to the variable, this attribute is going to make sure that the value is inside the interval, and if it's not, it's going to either bring it to 0 or 14, depending on whether it is below 0 or above 14. So what we're going to do is we're going to see actually how this property wrapper called @clamping could be implemented. So we're going to start by doing something very basic and that's going to feel very familiar to Swift developers. We're going to implement a struct. So this struct is generic. It has a generic argument, a generic type called value. We constrain it to be comparable because if we want to be able to say that whether something is inside an interval or not, it needs to be comparable. And then we are going to store some state inside this struct. We are going to store a value, and we are going to store a range, which is a closed range, and it's basically the range inside of which the value must be set. So until now, it feels very familiar. Then we are going to add an init. So this init, it takes a value and a range, and we are just basically setting the state of the struct, and we just add a precondition to make sure that the initial value is indeed contained inside the closed range, because if it isn't, it's probably a developer error and we want to fail. So we use precondition for this. So yeah. And then we want to actually have a property wrapper, because what we have here is just a good old struct. There is nothing new. So to actually get a property wrapper, it's kind of simple. You just need to add this attribute at the beginning of your struct. You say @property wrapper, and this lets the compiler know that, okay, clamping needs to be, you want to be able to use clamping as a property wrapper. So once you've done this, you're going to get a compiler error. It's going to tell you, okay, you need to implement something called wrapped value. So wrapped value, it's just a computed property. So there is nothing new here. What we can see is that we need to implement a getter and a setter. So the getter, it's pretty straightforward. We just return the value stored inside the state of the struct. And the setter, this is where we implement the behavior that we want to have, meaning we want to have the value be clamped inside an interval. So this is where we implement the logic of saying, okay, I don't want my value to be above the upper bound or not be below the lower bound. So the min and max logic, it's inside the setter. And basically, that's it. That's how you implement a property wrapper. With this type in your code base, then you can add this @clamping property. Now your code is going to build just fine. You can instantiate an instance of solution. And then if you set a value that is below the clamping interval, when you access the property, you're going to see, okay, now the value is 0 because we added a behavior in the setter. So -1, it was less than 0, so the value was clamped inside the interval, so the value was changed in the setter of the property wrapper. So when you see it, it feels a little bit weird. It feels a little bit like magic, but actually to understand it, we just need to understand that this is what we could call compiler magic, because basically, remember that we implemented this wrapped value property, and what's happening with a property wrapper is that whenever we write solution.ph, the compiler actually replaces it by solution.ph.wrappedValue. So in a way, a property wrapper is just the call to a computed variable that is inserted by the compiler at compile time. So this is what makes property wrapper very seamless to use, because we use them just like a property, and the compiler is going to add the call to the computed variable that encapsulates the behavior that we added inside the wrapper. A nice consequence of this is that property wrappers, you can use them in any version of iOS. It's something that's happening at compile time, so you don't need to, you're not limited by an iOS 13 version. You can use it on any version of iOS. Everything's happening at compile time. And of course, there might be time where you actually want to access the wrapper itself, not just the value inside it. So if you want to do this, you can implement another computed variable property, which is called projected value. So it's an example of how you could implement it. And then if you want to access the wrapper itself, you use the $sign before you call the property, and it will call projected value instead of wrapped value. So for instance, in our case of a chemical solution, if we do solution.$ph, we're going to get the property wrapper, meaning an instance of the struct clamping for a double, because we store a double inside our struct. So if you've seen SwiftUI code, for instance, when you have state variables, sometimes you use the $ when you want to pass it to another view, because you don't want the value that's inside it, but you want the value wrapped inside the state. So this is how this works. And so we can say that we've implemented a property wrapper that clamps a value between two other values, but of course, if we have applications that are very numerical, we could think of other use cases. For instance, you could implement a property wrapper to normalize a value. We could implement one that's going to round a value to the nearest integer. We could have one that would truncate the value, meaning keep only the integer part. We could quantize the value, etc. But of course, you might be thinking, okay, this makes sense for applications that are heavy on numerical computation, but of course, most iOS applications are not heavy on numerical computation. So we are going to look at some examples that are going to come up more naturally inside our apps. And we're going to begin by looking at how we could trim characters. So in our apps, we deal a lot with standardized formats, things like URLs or dates. And there is something tricky when we work with those formats, is that sometimes if there is a little mistake in a string that you are parsing, it can basically make the whole parsing fail. For instance, think about a URL that has a blank space at the beginning. If you try to parse it into a URL, it won't work, it will return nil. Same thing with a date. So it can be a really subtle cause for a bug, especially if the mistake is not in your code, but it's in a value that you are retrieving from a backend. So for such values, it might make sense when we get them to trim white spaces at the beginning and at the end, just to make sure that in the bad situation where someone made a mistake when they enter the value, we don't have a bug or we don't have like a feature missing inside of our app. So what we are going to do is that we are going to introduce a property wrapper that will do just this. It's going to trim the blank spaces and the new lines at the beginning and the end of a string. So we saw how property wrappers are implemented. So remember, we had the @property wrapper at the beginning of the declaration of a struct. Then we just declare some struct in Swift, so we call it trimmed. Inside we have a state, which is a value, and it's a string because we want to trim strings. Then we implement the wrapped value computed property. So the getter, like before, we just return the internal state, the value property that we store inside the trim struct. And in the setter, this is where we have the behavior. So in the setter, before storing the value, we call the function trimming characters in set, and the set that we give is the white spaces and the new lines. We provide an init, because this is what's needed in order to be able to call the property wrappers from our code. And that's it, that's how we implement it. And now, if we think, for instance, we have a blog post, we have a struct called a post, and it has two properties, a title and a body. Both properties have been decorated with the @trimmed property wrapper. And then, so if we start by creating a post and we, by mistake, have some white spaces at the beginning and at the end of the string, actually, when we get the value from the string, we will see that there are no leading or trailing spaces. Why? Because the title property has been decorated with the @trimmed property wrapper. And so when the value was set, it went through the setter, and all the white spaces and new lines at the beginning and at the end have been trimmed away. And if we update the property, we also go through the setter and we get the same behavior. So it's kind of cool because if we look at the declaration of our post struct, we didn't have to add a lot of code to have this behavior. And moreover, this is very readable because when we look at the title, we see @trimmed. It makes sense that, okay, this is a string and it's going to be trimmed, meaning that we are going to remove the white spaces and the new lines at the beginning and at the end of the string. But we can also look at some use cases that have a little bit more of a business logic. So we are going to look at, for instance, data versioning. So what we want to do this time, we are going to implement a business requirement for a property wrapper. And what we want is to have a property wrapper that is going to manage an history of the values that have been assigned to a variable. Think, for instance, if you are using Swift on the back end, this might make a lot of sense because if you have some weird bug or some weird issue, you might want to understand how did we get to this state. And so if we have an history of all the values that have been set to a particular variable, it could help you debug an issue in a very efficient way. And we're going to see that it's actually quite easy to implement. So like before, it's just a struct. So it's called version. This time it's generic. And there is no constraint on the generic type value because we could store anything inside the struct. We have a state. So in the state, we store the current value. And we also store the history. So we call it timestamp value. And basically, it's an array of tuples. And in the tuples, we have the date and the value. So we are going to store all the old values inside this array, plus the timestamp of when they were set, because it's an information that is very useful and very actionable when we want to debug our code. And then we implement the computed property. So like before, the getter is just returning the value because we are only interested in the current value when we request, when we use the property wrapper. But in the setter, we want to do two things. We want to actually store the new value in the history. So to do this, we are going to use the keyword defer. So it's a Swift keyword that says, okay, the code that's inside the scope after defer is going to be executed at the end of the current scope. So meaning at the end of the setter. So we say we want to append the new value inside the history, and then we want to update the current value with the new value. And that's it. We just provide an init in order to have everything built well. And then, for instance, we could imagine that we have some class called expense report that is modeling a business logic. So we are working on an accounting application. And expense report, we say they can have 4 states. They can be submitted, received, approved, or denied. And the state, we decorate it with @version. And this way, whenever we update the state, the history is going to get updated. And this way, we will have a nice history of all the values that our state went through. And what's very nice is that if we were to make this class codable, we could also store the history inside the database, also in a very seamless and very easy way because we just have to add the property, the annotation @version and nothing more. So by just adding this annotation, now we have implemented a full, basically complete business requirements. So it shows that property wrappers, they are not just little toys or little helpers that can help us on some topics like numerical computation. They can also be used in a much broader sense within our code. And inside a real-world backend application, we could even go further. For instance, we could implement a wrapper called audited that would keep track of which user read or wrote from a given property. And when you do backend, it's something that sometimes you need because sometimes it's a business requirement to know which user accessed which data and when. So you can really implement full-fledged business requirement through property wrappers. However, you also need to understand there are some limitations. Basically, the biggest limitation that you have with property wrappers today is that property wrappers, they cannot throw errors. And it makes some interesting use cases, unfortunately, out of reach. Because think about if a property wrapper could throw, we could be implementing things like workflow mechanism. For instance, we were talking about expense report. You have states, but there are some rules between the states. For instance, you can go from submitted to accepted, but once it's accepted, it cannot go then to rejected. And same thing, if it had been like rejected, you cannot get it back to submitted. So if we were able to throw errors, we could implement even more powerful stuff like workflow that would throw errors whenever we would do something that is illegal. So unfortunately, we cannot do this yet. But still, as we saw, there are plenty of use cases that we can cover. So until now, we've used property wrappers, we could say in a standalone way, because the property wrapper was holding all the data that it was managing, that it was interacting with. But now what I want to show you is that we can also use property wrappers to interact with APIs. And to give you some nice and actionable example, we're going to have a look at an API that most iOS developers are familiar with. It's user default, the API that we use when we want to store information when we want to persist information in kind of a lightweight way. So this example, it's taken from the blog of Antoine Vanderly. So there is the link if you want to see the whole blog post. So this is the kind of code that you might find yourself writing today if you want to access property wrappers in a nice way within your app. You would extend user default, you would add an enum, where you would have all the keys inside your property, all the keys that you are going to store in the user defaults. And then for each variable that you want to be stored in the user default, you would write a computed variable. In the setter, you would set the value using the key in your enum. In the getter, you would use the key to retrieve the value. And it works really well, but there is boilerplate code. Because when we use it, it's nice, it's very seamless. We say user default.standard dot our computed property. We set it to true. We can also get the value and we can perform business logic. So it's nice because we have clean call sites, but it's bad because it requires boilerplate. We need to explicitly write a new computed property for every single basically value that we want to store in the user default. And actually, this is the perfect use case to use a property wrapper. So we're going to do it. So our wrapper is going to be called user default. It's going to be generic. And inside the state, we're going to store two things. We're going to store the key that we use to access and store the value. And we are going to store also a default value. Then we're going to write an init that takes the key and the default value and set the state of the wrapper. So nothing special here. And then we are going to implement the computed variable. So inside the getter, well, we call user default with the key, and we try to cast it, so using as question mark as an instance of t. And if either there was no value or the casting failed, we use the default value that was provided at init time. And inside the setter, we set the value inside the user default. And what I want you to see is that the difference between the previous wrapper that we saw is that this time, inside the wrapper, we are not storing the value. Inside, in the state of the wrapper, so the two properties, key and default value, we are storing how to interact with an external API, which is the user default API. And then, when we want to use the wrapper, it's much more easier, and there is much less boilerplate than before, because we just define a struct called user default config. Then we say we have a static var, and we decorate it with the @user default, to which we provide the key and the default value. and that's it. So we don't need to actually write a computed variable for every single time. Then we just have to declare it, and through the user default say this is the key and this is the default value. And then we can use it just like before, so we can set value to it. We can print it and see that, yeah, the right value was stored. We can update it. And if we read it again, we would see that indeed the value did change inside the user default. So it's really nice because basically we have smoothed out interaction with user default. And also you can think that the user default, this is kind of a good use case for code generation. And now we are able to achieve the same thing, but without code generation. We are staying in Swift, we are staying within the language, and we have successfully removed the boilerplate without introducing a tool like a code generation tool. So we've smoothed out interaction with user default, but it's an approach that we could definitely apply to basically any data store. So you could expect popular persistent framework like Realm, for instance, to maybe adopt this kind of syntax, or maybe other people will do it by writing some extension, but you could really have some nice persistent framework in which all the logic where you say this is how I want my value to be stored is provided through a property wrapper, and this way you basically get rid of all the need to write boilerplate code for like every single entity and things like that. So what we've seen is that property wrappers, like their name says, they operate on properties. So it might seem like something extremely obvious to say, but behind that there is another question, which is, wouldn't it be cool if we had property wrappers, but for function, like function wrappers in order to be able to decorate function? So property wrappers, they only work on properties. But you might remember that Swift is a language that really likes functional programming. We have lots of nice functional programming primitives like map, filter, and reduce built into Swift. And basically, in Swift, functions are what we call first-class citizens. So it basically means three things. It means that we can store functions inside variables. It means that function can take function as arguments. For instance, think of map. And also, one that is a little bit less known, but functions can also return functions. And basically, when we see this, we say, okay, so functions are just like any other type. So we can store a function within a property. So actually, property wrappers, we can definitely apply them to function. And we're going to see that we can also build some really cool stuff with property wrappers, because they will enable us to extend and add behavior not only to properties, but also to functions, so to code. So we're going to see a very simple use case. We are going to see how we could implement the caching of a pure function. So just to define the term, a pure function is a function that has no side effects, meaning it's a function that only depends on its argument. Think mathematical functions like sine and cosine, they are pure functions because for a given argument, they will always return the same value, which makes them functions that are very easy to cache, because once you have computed the result once, you just need to store it and return it for every subsequent code that uses the same argument. So how do we implement this? There's actually quite a lot of code, so we're going to see it step by step. So we begin by defining a struct which we call cached, and it has two generic arguments, input and output. We add a constraint on input that it must be hashable, because basically we are going to need to store the input in a dictionary, and for this it needs to be hashable. Then within our state, we are going to store a cached function. So as I said just before, we can store functions in properties. So this is a property, and it's a function that takes an input and returns an output. We are going to define an init, so nothing fancy here, just setting the state of the wrapper. And then we are going to look at the wrap value computed property, because basically, just like before, this is where all the logic is going to happen. So if we focus on wrap value, we can see that the getter, very easy, we just return the cache function. Like before, everything is going to happen inside the setter. So within the setter, we are going to first create our cache. This is where we are going to store the result of the calls to our function. So this cache, like as I said, is just a dictionary with input as a key and output as a value. Then we are going to give a value to the cache function property. So we are going to define a function. So it's a function that takes an input as an argument. And what we're going to do is very simple. We're going to look up inside the cache, say, okay, do I have a value in the cache for this input? If I do have one, it means that I've already made the computation, I have already stored the result, and I can just get it and return it. There is actually no need to perform the computation. And if I haven't, then I'm going to perform the computation. So I do this by calling new value. So new value is the function that was set to the property wrapper. So it's the function that takes an input and returns an output. I call it, I perform the computation, I get the result, I store the result in the cache, and then I return the result. And this way, the first time the call is made for a given argument, we go in the else branch, we compute the result, we store it, we return it, and then every subsequent call is going to go in the if branch, where we will only need to retrieve the value and use it. So it's a little bit more code, it's a little bit more maybe harder to understand because functional programming, what are you going to do about it? But when we want to use it, it's very easy. For instance, think about an app that would basically do some trigonometric computation. Maybe it can be something as simple as doing 2D games. Sometimes you need to perform trigonometric calls, and making a call to a function like cosine, it's a little bit expensive. Not that much, but it's a little bit expensive. And if you do it in a tight loop, it might maybe slow down your app. So what we want to have a cached version of the cosine function. So to do this, we have our struct. We say, okay, I want to have a static var, which is a function, which is a cached version of the cosine. So we decorate it with the @cached attribute, and then we set a value, and this value is just calling the cosine function. And then if we run this code, if we were to call it first time, so we ask to get the cosine of 2 pi, so it makes the computation. It makes it in like 48 microseconds. But then we know that since we use the cached property wrapper, the value of the cosine for 2 pi has now been cached. And if we make a new call with the same argument, this time we are going to get the same result, but it's going to be much faster. Now it's less than a microsecond, so you can see that we've gained basically 2 orders of magnitude. So it's pretty nice because we have implemented caching successfully. And what's also very nice is that we've implemented it in a way that is very, very seamless, and it didn't degrade the quality of our code. Sometimes when we want to add some optimization, we do it in a way that is going to degrade our code because we are going to add some new level of abstraction inside our code. Here, it's very declarative way. We just say, okay, I want this function to be cached, and that's it. Now it's cached. And of course, I've used it on a mathematical function because it's easier to explain, but you could also think like of a network call, a get network call. It's supposed to be cacheable. So if it is cacheable, you can use the same mechanism to cache a response and only make the call, the network call, the actual network call the first time, and then all the subsequent calls you use your cache result in order to save on battery life, networking data, etc. So cache is a nice example to basically understand how it works, but once you have understood the logic, you will see that there are many more use cases that make sense. For instance, we could implement property wrappers like delayed or debounced in order to deal with timing. We would give these wrappers basically a block of code, so a function from void to void, just a function that performs side effect. And we say, okay, I want this to be called, but with a delay of 3 milliseconds. Or I want it to be debounced, but with a delay of 3 milliseconds. So basically, many of the use cases that we find in of the tools that we find in frameworks like Eric Swift, we can implement them with property wrappers in our code base. We could also implement mechanism for thread safety. So by having a piece of code that whose execution would be wrapped around a lock, and the lock would be stored inside the property wrapper. So we could implement an @threadsafe property wrapper, etc. Basically, property wrappers, they are a very generic way of implementing things. So the use cases, they are almost limitless. It all depends on what you need in your app. And before we end, I want to do one last implementation. So remember at the beginning of the talk, I showed you how they do it on Android. And you might be thinking, okay, can we do the same thing with property wrappers? So we can't do the same thing yet, because for instance, if we wanted to implement a post call, you can see that there are several annotations inside the declaration, and a post, it has arguments, so it needs to have several annotations. And there is a limitation of property wrapper is that for the moment they cannot be composed. So you cannot have several property wrappers inside on a property cannot have several property wrappers. There are some discussion on how it should be implemented, but there are actually some tricky edge cases. So for the moment, it's not implemented. So we are not going to implement post. We are going to implement get because it's easier to basically implement with one property wrapper. So there's a lot of code. So we're going to go through it step by step. First, I'm going to do something that's going to help us a lot. I'm going to define a type alias. It's called service. So it's a way to implement a service that returns a response. And you can see that it's basically a function that takes a completion handler. This completion handler is going to give you a result that is either the response or an error. And it's going to basically make the function signature much more manageable to read. So how do we implement this property wrapper to make get HTTP call? So we create a struct called get. We say that it is a property wrapper. Then we store a state. We need to store only one piece of state, is the URL that we want to call. Then inside the init, we take string, because when we write code, we are going to give the URL as a string, and we turn it into a URL. In order to keep things short, I'm doing a force and wrap. In a real application, we would want to deal with it in a little better way. Then we implement the wrap value. So this time, we only have a getter because we are only going to make calls, so to get the service. We are not going to set a new service. So this is a read-only property. So as it says in the declaration, we are implementing a service. So we need to return a service. Remember from the type alias that service is just a function that takes a completion handler. So we are going to return a function. This function takes a completion handler. Then inside the function, we are going to use URL session to create a data task. This data task, we give it the URL that we stored in the state of the wrapper to make the call. Then we are going to add the logic to say, OK, was there an error? If there was an error, I'm going to call the completion handler and saying there was a failure, and this is the error. If there were actual data, we are going to decode it as a string. Once again, I'm doing a lot of force and wrap in order to keep the code short because it's already a big chunk of code. And if the decoding went successfully, we are going to call the completion handler with a success. And in the success, there is an argument, which is a string that was actually retrieved from the network. And then we just need to actually start the task by calling resume on it. And with this, we've implemented a way to make get HTTP call in a declarative way. Because now, inside our app, for instance, we could have a struct called API. Say, OK, I want to have a service that calls an API with the HTTP get method. So the URL, we give it as an argument of the wrapper. So at get, then there is the URL. This is a URL that's going to call the Open Weather Map API to get a sample of the API. So it's going to return us a JSON. And then we can call it in our code in a very seamless way. At the call side, there is no implementation detail whatsoever. We just say, OK, there is a struct called API. There is a service called getCurrentWeather. I can call it, and I can use the result to print it to the console. And if you run this code, you're going to see that you actually do get the data. So we are able to implement a network call in a very declarative way, kind of like what they do on Android with retrofit. So I do want to point out that this is more a proof of concept than a full-fledged implementation, meaning that you can only do get calls. You cannot really do post or put with this. You cannot do it in a way that would be manageable. So I wouldn't encourage you to use this in your app. But still, I think it's a nice example to see that property wrappers, they can be very broad, and they can provide a whole lot of properties from very low-level stuff that for things that like numerical computation to high-level stuff like making a network calls, things that have a bigger technical stack behind them. So that was a lot of information in those 40 minutes. It's time for a recap, I think. So recap about property wrappers. What should you remember about this talk? First, you should remember that property wrappers, as their name states, they let us wrap properties with custom behaviors. You should also remember that they are very good at removing boilerplate code. Think, for instance, when we interacted with user defaults. So if you have some use cases in your code where you are using code generation tools like sorcery, for instance, you might be thinking, could a property wrapper help me improve on this situation? Because property wrappers, they have the advantage that they are part of the language. They don't require an external tool. So it can be a good trade-off or a good alternative to code generation. They also provide some really nice ergonomics for constructs that are ubiquitous. So things that are going to be used everywhere inside your app, like maybe trimming characters if you are writing a server-side application. It might make a lot of sense to have it because you might find yourself using it everywhere in your app. And when you have this kind of situation, a property wrapper is going to help you remove a lot of code because you won't have to explicitly call a method or explicitly add a behavior to all your entities or all your structs. You need also to remember that property wrappers, they actually not only apply on data, but they also apply on functions, and we can implement some really nice mechanisms. We saw the example of caching the result of function, but we can also implement things like delaying or providing thread safety to property wrappers. But you also need to remember that they can hurt code readability if abused. Like any good things, you need to use them in a reasonable way. That means the name must be very clear, because the name is the only piece of documentation you get when you read code. So if the name is not descriptive enough, or if the name is tricky, you might find yourself degrading the readability of your code. And of course, if you write a property wrapper that takes like a dozen arguments, yeah, you're also hurting yourself. So you need to ask yourself, am I going to use this a lot in my app? And if I go back to the code like 1 week, 1 month later, am I going to understand what this property wrapper does? If the answer to both of these questions is yes, then property wrappers are going to help you. If it's no, maybe you should either just use a struct and make the explicit calls to a computed variable, or maybe use another solution, because property wrappers, they can hurt your code if you abuse them. And finally, property wrappers, they are very new. They were introduced in June, so it's just a few months ago. But we have definitely not seen the last of them because SwiftUI uses them a lot. There are chances that framework we will get in the future will use them a lot. So it's probably the start of something new and exciting. And it's going to be very interesting in the months to come to see what it will evolve into. Thank you all for your attention.